Two lines could be graphed, and what would happen? They intersect, and you get a point of intersection, which is your solution? Or what else could happen? Well, if they go different ways, they'll eventually intersect, right? Or they're parallel, so they never intersect, and what was that called? If they never intersect? No solution, yes. And what was the third situation? Many solutions. That's when the two lines are actually the same line. Oh my gosh. Okay. So a solution set of a system is all the ordered pairs that satisfy all equations in the system. For example, 2, 4 is the solution of the system of the line y equals x plus 2 and the parabola y equals x squared. The coordinates 2, 4 satisfy both equations. Can you find the other one? So what I mean by 2, 4 satisfies that, if I substitute x with 2 and y with 4, does everybody see? I get 4 equals 2 plus 2, which is correct, yes? And if I substitute it into that one, I get 4 equals 2 squared, which of course is correct. Can anybody think of another possible solution that would work? Anybody? So negative 1, 1, let's check. So 1, in the first equation, you'd get 1 equals negative 1 plus 2, which, yes, that does work there, right? And if I put it into the other one, I get 1 equals negative 1, the whole thing squared, which does work. Very good. We found another one. Okay, so obviously there's a better way to find it, not just randomly picking stuff. Okay, so we're going to go over review of grade 10 when we had systems of linear equations. And when we had no solution, that was two lines that never intersect, or parallel lines, yes? When we had one solution, essentially we had one line going one way and the other line going another way, and they intersected in one spot. And then the many solutions was one line, and it turns out that it ends up being the same line. So the reason why it's infinitely many solutions is, does everybody understand a point is just, sorry, a line is just a point, and many points just so close together that it forms that solid line. So that's why all these things that are intersecting on that line are the solutions. So if you pick any point on the line, it'll work when you sub it in. All right, so recall from 20s, I know it was a long time ago. You could solve the system by graphing. What was wrong with graphing? It takes a while. What else is wrong with it? I'm sorry? Yeah, the intersection might be between 2 points, so then you're kind of just estimating where it is. Also, if you didn't actually graph like really precisely, you're off, right? It's not a very accurate method unless you use your graphing calculator, which would graph it precisely. Okay, the elimination method, or I think some people called it the addition-subtraction method, where you lined it up and then you added them together or subtracted and something eliminated. Do you remember that? Yeah. It'll ring a bell in a second if you don't. And then what's called the substitution method, where you solve for one variable and plug it into the other equation to solve. Okay. So, I don't know what happened there. We're going to solve by graphing. So, what is the easiest way to graph this first line? Find the intersects. Okay, so what is the intersects here? What's the x-intercept? What is it? Anybody? 9 over 2? Or 4.5? 4.5? Okay, what's my y-intercept? That's an easy one, right? It's 3. Okay, so this is where you have to be fairly precise here. So this is my y-axis, my x-axis. And you have to use a ruler. So we're going to put a point on the x-axis at 4.5. 1, 2, 3, 4.5. And the y-intercept is at 3. I'm going to take my line and I'm going to connect the dots. But obviously, you can't do a short stubby line. I'm going to extend it now. I couldn't at the time. So I'm going to extend it and extend it. Okay, so then now I have the first line drawn. Any questions how I got that first line? Okay, so the next one, this is in standard form as well. So x and y intercept graphing is key. So what's this x-intercept going to be? Does everybody know what I'm doing here? Yeah, 2. And what's the y-intercept going to be? -2. A point on 2 and a point on -2. And then I'm going to connect the dots here. Again, I need to extend it. So there we go. And what's my point of intersection? 3, 1. POI 3, 1. Do you remember writing it out as POI or point of intersection? Prince Edward Island. It's PEI. Okay. How do I check to see if this is right? You need to sub it into both, not just one, but both. Okay, because it has to work for both. So 2 times 3 plus 3 times 1 equals 9. Does that work? That worked, yes. And then 3 minus 1 equals 2. Does that work? Yes, so this is my solution. 3, 1. Okay, ring a bell? Okay, so next one, it's kind of weird how the first equation is written. I don't know, maybe not. Okay, so what do you want to do then? We can do x and y intercept graphing, but it's not really nicely written. So I could move this one over to the other side. Okay, so I'm going to move the 1 over to the other side so I get x minus y equals 1. Is everybody good with that? So what's my x-intercept? What's my x-intercept? 1. What's my y-intercept? -1. Let's plot. Yx, here is 1 and -1. I take my line, continue it. Yes? Everybody good with that one? Okay. Then, next one. What is my x-intercept? What's my x-intercept? -2. Everybody got -2. What's my y-intercept? -4. Very good. Okay, so I'm going to plot -2, -4. 1, 2, 3, 4. And then I'm going to connect the dots with my ruler. Looks like I'm off a little bit. Okay. So what's my point of intersection look like? It looks like -1, -2. And how do I check to be sure? Substitute. I highly recommend algebra. You can get 100% every time by just checking, right? So, into the first one. Now, always sub into the original, not something you manipulated because you might have made a mistake in the manipulation of it, right? So, -1 subtract -2 minus 1 equals 0. That's the first one, right? With the -1 on the other side. So remember, if you have minus, what does that become? Plus. So -1 plus 2 minus 1, is that 0? Yeah, that worked. Okay, now I'm going to put it into the second one. 2 times -1 plus -2 equals -4. Is that correct? Yes. Okay, how about you guys try the next one on your own? X-intercept is 5/2 or 2.5, and your y-intercept is 5. So 2.5 and, oop, I'm a little off there. And 5, 1, 2, 3, 4, 5. And then we're going to connect the dots. Now, of course, not everything works out so nicely. So when I assigned the homework, I made sure that I try to pick ones that work out nicely, just so you don't get too frustrated. Okay, so x-intercept is 4 and the y-intercept is -4. 1, 2, 3, 4. 1, 2, 3, 4. Okay. And it looks like my solution is right here, which is 3, -1. And I would check it. 2 times 3 minus 1 equals 5. That works. And 3 minus -1 equals 4, and that works. Did everybody see? I highly recommend checking. Okay. So let's think about linear quadratic. That means I have a line and a parabola. What could happen? What could happen here? We could have no solution. So what would that look like? Maybe I have a parabola upside down, right? And a line way up here. Does everybody understand why that's no solution? They don't intersect, right? Or I could have a parabola way up here and a line way down there, and it'll never intersect. No solution. Okay, how would I have a line and a parabola and only get one solution? Okay, you could have, I like that one. You have a vertical line. It only goes through once. Okay, can anybody? It only touches the vertex. Very good. That's the other situation. Who said that? Whoops, I totally missed it. There, that's supposed to, right at the vertex. Or it doesn't have to be horizontal. It can be like a tangent line. It can be going like that as well. It just has to just hit it. And then two solutions, of course, you could have a parabola upside down and a line going like that. So you get two intersections. Or a parabola like this, and it's the line like that. Does everybody see how you get two solutions? Okay, how about a quadratic? Yeah, one's opening up and one's opening down, and they never intersect. Yes? What about one solution? Yeah. Like that. Or you could just have it as a tangent like that. That kind of looks, I don't know. Go sideways. Yeah. Something like that. Huh? Yeah. Let's graph the first one. Who can tell me how to graph y equals x squared minus 4? Starts at -4 on the y-axis, yes. 1, 2, 3, 4. It's opening up, and it has the base pattern of 0, 0, 1, 1, 2, 4. Yeah? We might have to go to 3. What would that be? 3, 9. So 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. Does everybody see why I thought that? Yeah. In the next line, the next thing we have to plot is y equals 5. And that is a horizontal line going through there. So does everybody see what my solution is? Yeah. It's these two 3, 9 spots. So what is that? 1, 2, 3, 1, 2, 3, 4, 5. So 3, 5, and negative 3, 5. And let's plug her in and make sure it works. Well, 3 squared is 9. 9 minus 4 is 5, so that's right. And negative 3 squared is 9. 9 minus 4 is 5. And then how does the second one work? You just plug 5 in for y, and 5 equals 5. That, of course, works. Yeah. So it works. What do we have to do for the next one? Yeah, factoring will tell you what the x-intercepts are, but completing this square will tell you the vertex. So y equals x squared plus 6x, and I'll put a plus 7 over here. So what do we do in this process? We take half of plus 6, which is plus 3, and if I square it, I get plus 9. I can't just do that, so I minus 9 at the same time. And so this part of this is that completing the square, and what's 7 minus 9 simplify to be? Minus 2. So my vertex is at, try again, minus 3, minus 2. So here's my y, here's my x. 1, 2, 3, 1, 2. There's my vertex. Everybody got that? And this is a nice base graph. So 0, 0, 1, 1, 2, 4. Yeah? We might need to go 3, 9 just to be on the safe side. 1, 2, 3, 1, 2, 3, 6, 7, 8, 9. Just to get a nice shape to it. Yeah? Okay. I'll maybe wait till everybody has that done. And then how would you graph y equals negative x minus 3? That's in slope-intercept form, right? It's in slope-intercept form. So we put a point on, negative 3, and then what? It's a negative slope, so we're going down 1 over 1. Or you could go up left, but either way. I'm going to get my ruler out to do this, because I want to make sure this intersects in the right spot. Oh, look at that. Beautiful. Okay, so it looks like there is an intersection at, what, negative 2, negative 1, and 1, 2, 3, 4, 5, 2. Okay, so I'm going to check, though, because it's a little bit, I can see my point is right there. I can see my point's right there, but I'm still going to pick. So again, sub it into the original. So if I substitute negative 2 and then I square it, I get positive 4. 6 times negative 2 is negative 12. So 4 minus 12 is negative 8. Plus 7 is negative 1. So it works in the first one. Let's see in the second one. Negative 1 goes in for y. So this right side has to equal negative 1. So negative 2, but this is negative negative 2. So really that's plus 2, subtract 3, which is negative 1. So this one checked. So let's check to see if 5 works. 2, sorry. 5 goes in there. 5 squared is 25. 5 goes in there. 6 times 5 is 30. 25 and 30 make 55, and 55 and 7. Oh, shoot, it is negative 5. Thank you for catching that. See, this is why we check, right? Okay, let's try again. Negative 5 goes in there, and I square it. I still get positive 25, but this time when I put negative 5 in there, I get 6 times negative 5 is negative 30. So 25 minus 30 is minus 5, plus 7 is 2. So it works there. Sub her in back there. Negative negative 5 is 5 minus, so that one checks. So, see? That's why checking works. Okay, last one. I want you to try on your own. Okay. So x squared plus 2. Two, 4, 1, 2, 3, 4. Okay, so there's my first one. Now the second one, you have to complete the square, right? So y equals negative bracket x squared minus 2x plus 6. Did everybody see what I did when I was completing the square? I need to factor the negative out. Now I'm going to take half of minus 2. So it's going to be minus 1 squared is plus 1, but really I subtracted 1, which means I need to plus 1, so it's plus 7. So it is 1, 7. 1, 2, 3, 4, 5, 6, 7, and it's opening down. So you can see right away, there's your first intersection. 2, 1, 2, 3, 4. There's your second intersection. Isn't that beautiful how they intersect so nicely? So what is that? 2, 1, 2, 3, 4, 5, 6. Is that right? 2, 6. And the other one is what? Negative 1, 3. So let's check to make sure. 2 goes in there. 2 squared is 4. 4 plus 2 is 6. So it checks in the first one. 2 goes in the second one. 2 squared is 4 minus 4. Plus 4 is 0. And that one works as well. Negative 1 goes in there. Negative 1 squared is 1. 1 plus 2 is 3. So that checks in the first one. Negative 1 squared is 1. But then you still have a negative. Plus 2 times negative 1, so negative 1 minus 2 is negative 3, plus 6 is positive 3, which checks as well. So there you go.